If you have known our IP6704A before, you might want to learn about our IP6704A DACS. Even though they look no different compared to IP6704A, IP6704A DACS might be a better solution. So, what makes this IP6704A DACS stand out? IP6704A DACS not only retains all the features of IP6704A, but also has cross-connect capability that supports full non-blocking DS0 cross-connect matrix between TDM interfaces and TDMoE pseudowires, is suitable for DACS, digital access cross-connect system, and ADCB add-drop channel bank applications, and is able to perform auto A-low to mu-low conversion. Now let's take a look at our IP6704A front panel. Here we can see two FE1 T1 in ports A and B. Right beside them, we have 4 Ethernet ports with 2 SFP and 2 RJ45 electrical ports. The console port is on the upper left. And finally, on the upper right area, we have 2 daughter cards, which are manufacturing options in port C and D. For the daughter cards, we support several optional interface modules, including TDE cards, analog voice cards, telecom cards, and power teleprotection cards. The next one is the rear panel of the IP6704A. Here we provide 2 power options. The first option is with up to 2 DC power in 2 pluggable slots. Customer may choose to purchase only 1 power module, as the second module is for redundancy. For the second option, we have a hybrid AC and DC fixed power supply. And we can see that the DC power is on the left and the AC is on the right. Next, we will talk about the capacity of the IP6704A. For ports A and B, we have 1 FE1 in each port, and in ports C and D, we have 4 FE1s in each port. Therefore, the total number of FE1s here is 10. Now let's see the pseudowires. The pseudowire hereafter mentioned in this video is an emulation of a point-to-point connection used to transport service, such as TDM, SDH, over packet switch network like Ethernet, MPLS, and so on. The IP6704A can provide pseudowires via one of the Ethernet ports here, and the maximum number of the pseudowires can be up to 16. As shown in the table, the IP6704A has 2 fixed mini slots, which we can plug in the daughter cards as mentioned earlier. For the FE1 T1 ports, as we have just introduced, we can have up to 10 FE1 T1 ports, and for the pseudowires, we can have up to 16 pseudowires. As to the cross-connect capacity, for IP6704A without DACS, only pseudowires have the cross-connect capacity. As mentioned earlier, we have 16 pseudowires. Each pseudowire has 32 time slots, so here we have 16 times 32 time slots. And each time slot is equal to 64 kilobit per second. Therefore, the capacity of the cross-connect for IP6704A without DACS should be 32 megabit per second. For IP6704A with DACS, both of its pseudowires and FE1s have the cross-connect capacity, and it has 10 FE1s and 16 pseudowires. Each FE1 and pseudowire has 32 time slots, so the total number of time slots should be 26 times 32. As mentioned earlier, each time slot is equal to 64 kilobit per second, and therefore, the capacity of the cross-connect for IP6704A with DACS should be 52 megabit per second. Now we will introduce how this IP6704A works in practical application. The first one we're going to present is the point-to-point application. Here we have a frame T1 and a 1 E&M port on each side IP6704A number 1 and IP6704A number 2. Then we use the CESoPSN protocol to create a pseudowire to connect both sides. In this example, the frame T1 uses time slots 1 to 23 and the one E&M uses time slot 0. Then we bundle them together to create a pseudowire. This point-to-point application can also meet the needs of those clients who need low-speed signals for control and protection, such as RS-232 for SCADA, FXX for telephones, and C37.94 for protection. These clients may have a very nice Ethernet network but an old TDM equipment without support or spare parts. With the IP6704A, they can still use RS-232 to transmit signals from sites to sites based on their WAN network when the TDM network is not available. Next, we will present you with the local DACS application. In this example, the T1 from port A uses time slot 1. Then it goes through the DACS circuit, maps to time slot 4, and finally outputs to the port B. This is a simple DACS application, and we can also connect the IP6704A to other equipment, such as our AM3440 on this end. Now let's take a look at this detailed diagram about IP6704A without DACS from port A to pseudowire. From the diagram, we see that there is no DACS circuit in FPGA. On the left, we have an input port. In this example, we use the port A to connect an E1, and it will go to the output side on the bottom right to build a pseudowire, and then it will go to the Ethernet port. This Ethernet port can be Ethernet port number 1, number 2, number 3, or number 4. Let's see another diagram without DACS from pseudowire to port A. Here is where the Ethernet pseudowire be input from, and it will go to the port A and output E1, for example. The diagrams displayed earlier are IP6704A without DACS version, and now let's see how IP6704A works when DACS is included. From the diagram here, with DACS from port A to pseudowire, we see a DACS circuit in FPGA. The data from input port A, will go through the DACS circuit and pseudowire, and then output to the Ethernet port. The next one is from port A to port B. Here the data is input from port A, and it would also go through this cross-connect module, then it will be output to port B. Finally, we have this diagram showing that the data is input from pseudowire, the Ethernet port, goes through the cross-connect module, and then is output to port A.